Chapter 4: Mobile Application Platforms, Tools, and Environment. 4.1 Development Platforms for Mobile Applications. Integrated Development Environments (IDEs) are available on the market for various mobile app developments. These IDEs have various tools that help in designing, coding, compiling, installing, deinstalling, monitoring, emulating, logging, and testing apps. For example, Android Studio may be used for Android app development, and for iOS app development, Xcode may be used. These differ from normal IDEs by the added support they offer for the mobile platforms. Some cross-platform development frameworks are also available, which helps in the development of mobile applications. These run on multiple platforms and do not specifically require coding. 4.2 Common Development Platform Tools. Software development kits usually provide various utilities which are helpful in developing and testing applications. These utilities span a wide range of purposes, such as taking screenshots, extracting logs, sending random events and notifications to the device, monitoring various parameters such as memory and CPU utilization, and creating virtual devices. Some examples of such tools are Android Virtual Device (AVD Manager), Android Debug Bridge (ADB), and Android Device Monitor for Android and Instruments for iOS. 4.3 Emulators and Simulators. 4.3.1 Overview of Emulators and Simulators. In the context of this syllabus, the terms emulator and simulator refer to mobile emulator or mobile simulator. The terms simulator and emulator are sometimes used interchangeably, but incorrectly. For definitions, please refer to the glossary in Chapter 8. A simulator models the runtime environment, whereas an emulator models the hardware and utilizes the same runtime environment as the physical hardware. Applications tested on a simulator are compiled into a dedicated version, which works in the simulator but not on a real device. Thus, it is independent of the real OS. By contrast, applications compiled to be deployed and tested on an emulator are compiled into the actual bytecode that could be also used by the real device. Simulators and emulators are very useful in the early stage of development, as these typically integrate with development environments and allow quick deployment, testing, and monitoring of applications. Simulators are sometimes also used as a replacement for real devices in testing. However, this is even more limited than the usage of emulators, as the application tested on a simulator differs at bytecode level from the application that will be distributed. Emulators are also used to reduce the cost of test environments by replacing real devices for some of the testing. An emulator cannot fully replace a device because the emulator may behave in a different manner than the mobile device it tries to mimic. In addition, some features may not be supported, such as multi-touch, accelerometer, and others. This is partially caused by limitations of the platform used to run the emulator. 4.3.2 Using Emulators and Simulators. Using emulators and simulators for mobile testing can be helpful for various reasons. Each mobile operating system development environment typically comes with its own bundled emulator and simulator. Third-party emulators and simulators are also available. A tester may use whichever emulator or simulator suits their purpose. Using the emulator or simulator requires launching them, installing the necessary app on them, and then testing the app as if it were on the actual device. Usually, emulators and simulators allow the setting of various usage parameters. These settings might include network emulation at different speeds, signal strengths and packet losses, changing the orientation, generating interrupts, and GPS location data. Some of these settings can be very useful because they can be difficult or costly to replicate with real devices, such as global GPS positions or signal strengths. Connecting to the emulators for the purpose of installation might require using command line tools such as for Android Debug Bridge, ADB, for Android, or connecting from within the integrated development environment as with Xcode or Android Studio. 4.4. Setting up a test lab. The following approaches are used to set up a mobile test lab. On-premise lab. With an on-premise lab, all the devices, emulators and simulators are located on site. Device selection can be done on the basis of various factors such as rank of the device, as found in Google or other analytics, operating system and versions, screen dimensions and density, availability and cost, special features, and importance in targeted audience. On-premise lab advantages include the availability of devices for specific proximity-based testing and sensor-specific aspects such as battery, touch, and enhanced security. Setting up this type of lab may require large budgets depending on the devices to be procured and maintained. Additional challenges include timely availability and difficulties with testing in different locations and environments. Remote test lab. These labs are important and helpful for testing when devices or network are not physically available on site. Remote Device Access (RDA) allows access via a network connection to various devices hosted in the provider's data center. Each potential RDA provider needs to be evaluated for compliance with the requirements, especially for security. Some remote labs provide the following additional features: dedicated physical device versions, e.g., Samsung Mobile Devices Lab; generic devices for a particular operating system and version only; robotic arms for performing touch and gesture-related operations; virtual private network (VPN) connections to give access to the device; cellular connections with various cellular network providers; automation tools and services. Some of the factors to be kept in mind when using remote test labs include slow device responsiveness and limited options for interacting with devices such as multi-touch and gestures. This can be cost-effective for sporadic use, but is generally more expensive if used for extended periods of time for a wide range of devices. Other factors include on-demand platform availability compared to the need to obtain access to missing devices in the local lab, and scalability of the lab, as it can grow and shrink as the project evolves. Test scenarios that include sensors such as NFC or Bluetooth or battery consumption are often hard to test in the cloud. However, the different geographical locations of remote labs may help with tests that need network and GPS connections. A test lab can utilize either one or a combination of the two approaches, depending on the type of tests that need to be performed.